For number 14, now we're solving a logarithmic equation, and with log equations we want to gather the log terms, combine all the log terms into one on one side. On the other side we're just going to keep that a 1. So if we had logs on both sides, we would still combine all the logs on each side of the equal sign, and then we would handle the rest of it differently. But for right now, we have logs on one side. We can't convert this to exponential form yet. We can only convert to exponential form when we have one log expression on the left side of the equal sign. So notice that we have the sum of the logs. The logs have the same base, and so we get the log of the product. The sum of the logs is the log of the product. So x plus 6 times x plus 2, and that is equal to 1. And so we notice that the variable here is locked up in the argument, and when that happens, we want to unlock that. So in this case, we have the log expression on one side, a real number on the other side, so we're going to convert to exponential form. So we write this as the base raised to the right side, 5 to the 1 power, is equal to x plus 6 times x plus 2. Well, we have a quadratic equation. At least we should recognize that we have that. And so having a quadratic equation, we're going to multiply out the right side using the FOIL method, first times the first. And then we have 2x, outsides is 2x, insides is 6x. So 2x and 6x is 8x. 6 times 2 is 12. Subtracting the 5 from both sides, we're going to get x squared plus 8x plus 7. So be careful about that. Double check. Minus 5, 12 minus 5 is 7. Good. And now we have one side equaling 0, so we're going to go ahead and factor now. So factors of 7, 7 and 1 that add up to 8 would be x plus 7 times x plus 1. Which means when we set each factor equal to 0, we get x equals negative 1 and x equals negative 7. But with log equations, you have to be really careful. You have to think, okay, well, can I replace x in the original equation with the values that I get down here? Well, x equals negative 1. If we replace x with negative 1, we see that we're taking the log of a positive number. And let's do that up here. So just above it, we're going to replace x with negative 1. So we get log base 5 of 5, that's 1. And if we replace x with negative 1 here, we get log base 5 of 1. And we know that the log base 5 of 1, or log base anything of 1, is 0. So does that equal, 1 plus 0 does equal 1. So therefore, x equals negative 1 is a solution to the equation. Likewise, we want to check negative 7. Well, if we check negative 7 and we replace x with negative 7, that means we're going to be getting negative 7 plus 6, that's negative 1. If we try to take the log of a negative number, we'll be unsuccessful because you're not allowed to take the log of a negative number. You're not even allowed to take the log of 0. So negative log base 5 of negative 1 does not exist. So therefore, x equals negative 7 is an extraneous solution. So therefore, x equals negative 1 is the only solution. And I'm going to go ahead and pause the video and move to the other side. Here we see on the back side of the practice quiz that we've got to graph a function, and we've got transformations just like we've had transformations all along throughout all of the other 8 parent functions that we've studied. And this is the logarithmic function. Okay, so we've got a logarithmic function. Well, a couple things to point out. The a is negative. A is less than 0. In fact, a is negative 1. And if a is negative 1, we're going to flip the original graph over the x-axis. We should notice here that our h value is negative 4, and our k value is negative 2. So these are very important numbers, and let's see how they work. Well, originally our log function, if we remember correctly, the log function looks something like this, where logs being inverses of exponential functions start slowly and then hit a key point, and then they grow quickly. Well, log functions grow quickly in the beginning, hit that key point, which is at 1, 0. Remember, the exponential key point is 0, 1. And then once the log functions hit that key point of 1, 0, then they grow very slowly. So the x values grow a lot quicker than the y values do. So I'm going to leave it at that and then pick up the rest of this in the next video. So I'll see you then.